The questions that we are going to discuss in this session, even if you are fully sure that you have done it correctly, still I would recommend you to watch each and every solution, each and every step, because I am not only discussing the solution, I am doing a 360-degree analysis of the question. Okay, not a very detailed one because time is limited, that is not permitted by time, but I love to do that analysis, right? But I will be discussing not only the detailed solution, but what are the possible variations of the question, right? Because it is memory based, there can be few things here and there that can change the answer, as well as what are the possible silly mistakes that you would have done even in the very simple looking question. So even if you have correctly solved this question, you are very sure, still I would recommend you to watch each and every solution carefully. Let us start. The fluid mechanics in GATE 2021 forenoon session, I would say it was very easy. It should be a full scoring topic, a full scoring subject of GATE 2021 forenoon sessions. The questions that we have verified so far, because I don't see any point in explaining half known questions with half explained solutions. I totally believe that the questions that should be discussed and the solutions that should be explained should be well organized and well explained, right? Because that will not only give you an idea of what mistakes might be possible while solving the question, you might have done those mistakes, or it will also teach you the concepts that may help you further. Okay, so let us start with this question of fluid mechanics. The fluid mechanics, the weightage of different subjects, I have already compared in a separate short analysis, right? So fluid mechanics had a decent weightage. This question, the first question of fluid mechanics that we are going to discuss, may look slightly complex. Initially, if you look at the question, it may look complex to you, but the questions even complex than these we have discussed in the video course as well as in test series, right? In this case, let's first understand what is going on, and after that I will tell you what are the possible confusions and mistakes in this question, and then we will solve it. If you look at this question, the question says, I'm not writing the full language of the question. In some question I will write, in some questions I will not write, because exact language is not known. Practically these are memory based questions, right? Language can change the question also, can change the answer also, but whatever information we have collected and verified, on the basis of that I am explaining this. So there is a jet of water. The density of water is 1000 kg per meter cube. That jet of water is striking a plate, a straight solid plate, as we have shown here. The diameter of the jet before striking is 1 centimeter. Okay. This plate is supported by a spring with a stiffness of 1 kilonewton per meter. Please pay attention to the units also, because we have kilonewton, then we have meter also, then we have centimeter also. The diameter is also in centimeter. So the units are continuously changing. So you need to be careful about that. This is supported by a spring of stiffness 1 kilonewton per meter, and the deflection of the spring due to this impact is 1 centimeter. Okay. You have to find out that what should be the velocity of the jet that will cause the deflection of 1 centimeter. This is the question. Now, in this question, some of the students may get slightly confused at a point. I will tell that point while explaining the solution. So this is the free body diagram of the jet. The jet is applying a force in the downward direction. The spring is applying a force in the upward direction. Now, pay attention here. The question that I have right now, it does not mention that how much is going to be the length of the jet. Please pay attention here. Because if length of the jet was given to you, then that length of the jet is continuously sitting on the plate in the steady state situation, right or not? So the weight of that column, weight of that jet will also be added in the force of jet. So the force in the downward direction will be force of jet as well as the weight of the jet. Because this is a different, slightly different case, although we have discussed the vertical jets. If you look at the examples that I have already discussed with you in the course, some of them also I discussed on the YouTube channel of Exergic. So such cases of vertical jet we have already covered. But in this case, if length was also given, then weight of the jet will also act on the plate, right? But the data that I have so far, length is not known. So if length of the jet is not known, you cannot find out the weight just by the density and the diameter. You need the complete dimension to be able to calculate the volume, multiply that with the density to get the mass, and after that you can find out its weight. So that may be something that if language of the question mentioned the length of the jet or diagram mentioned, then that might be considered. It depends upon the language of the question, which exact one we don't have right now. Anyway, in this question, length of the jet is not given in the diagram or in the question as far as memory based data is concerned. Okay, so we are only going to consider the weight of the jet. We are not going to consider the acceleration due to gravity, the gravitational force, the weight. Okay, so weight of the jet in the downward direction is equal to the force of the spring. Now spring is getting compressed, so obviously compressed spring will apply a force that will push it up. So both of these forces are in opposite direction. Now this case is a case of steady state. Again, this is something that I'm sure question would have mentioned somewhere. If it was not mentioned, obviously we will consider it to be steady case, because the velocity of the plate is not given to you in the question. For any such case of steady state, downward force should be equal to the upward force, right or not, when the body is not accelerating. No such data is available to us of the acceleration of the plate. So the force of the spring, let's calculate that first, then force of the jet, then we will equate them. The force of the spring is K del, nothing new here. K is given in kilonewton meter, we will convert it into Newton meter. Del value is given in centimeter, we have converted that to meter, we will get a force of 10 Newton in the upward direction of the spring. Since we have already considered the direction, so don't worry about the sign and all, right? The force of the jet, rho a v square. Again, a point where some of the students may get confused. That sir, if jet is striking this plate, plate will move down. So that downward motion of the plate, why we are not considering, sir? Why we are only considering it like a stationary plate? Again, I would ask you to recall the example that I have discussed with you. In the example that I discussed with you in the course, I told you that such cases are steady state cases unless something else is mentioned. At steady state, it's not accelerating. Initially, when it was in the transient state, then this spring was relaxed, plate was kept over that, right? The force of the jet will deflect the plate, will deflect the spring. That is the unsteady case, when it is setting up, when the jet has just started, right? But once it has compressed the spring, the force of spring will balance the upward force, it will not move after that. Right? This is the case that we are discussing, that it has deflected by 1 centimeter, it has reached the steady state now. So that movement of 1 centimeter is not the case that we have to consider here. The velocity of the plate that we consider while discussing impact of jet, in that case it is the steady velocity with which it is continuously moving. Recall, the impact of jet application is hydraulic machine. In Pelton wheel, we do this exact analysis, but in the Pelton wheel, the buckets are moving with a constant velocity, right? Buckets are not moving and stopping, moving and stopping. So the buckets or the plates or these surface has to move with a constant velocity if you want to use the expression where velocity of the plate is considered. This is not the case. There, the case is of steady state. It has reached steady state, and at steady state, it is at rest. So rho AV square is the expression. Just equate both of them. Rho is 1000. Area you can calculate from the diameter of 1 centimeter. Diameter is given, means it is circular jet. So pi by 4 d square you can use, and just equate them. Solving will give you the velocity of the jet as 11.28 meter per second. Alright. Now let us have a look at the next question from fluid mechanics. A fully developed steady laminar flow exists between two parallel plates. Fully developed means from here to here, everywhere profile is fully developed, it is not changing, it is steady. It's laminar means it is viscous. Viscosity is going to play a role here. Obviously it will. Between two parallel plates, so you can see the two plates are parallel. The diagram is also given. You can see that one plate here, I missed to write that. One plate here is fixed plate or stationary plate, and the other plate, which is parallel to the first one, is moving with a velocity of 4 meters per second. The gap between two parallel plates is 5 mm. So although in diagram it may look large, but it's very small. 5 mm gap is there between the two parallel plates. They are almost very close to each other. Between them, the fluid exists between them, the fluid exists which is having a density of 800 kg per meter cube. Most probably it's some oil, right, because density is lesser than 1000. And the kinematic viscosity is given. Since it's memory based, so I don't know whether kinematic viscosity was directly written, or if it was not written, you had to look at the sign at the units. That will give you a clear idea that it is kinematic viscosity. Okay, the shear stress acting on the moving plate is how many pascal on this plate. Okay, first point to understand here that it is the kinematic viscosity, not the dynamic one. You need to use dynamic viscosity in the calculations, so that conversion is needed. Point number 1. Point number 2, the shear stress is asked on the moving plate. If you want to calculate the shear stress, this is the expression that we know in such a situation, right? The variation of velocity with respect to the vertical distance with respect to the altitude or height should be known to you. But in this case, that is not given. The velocity profile is not given to you. Now, this is something that I have repeatedly told you while explaining the concept also, as well as in the different courses, that whenever question does not give you the velocity profile, you can use the linear profile. You can take the variation of velocity to be linear like this, right or not? Especially in this case, when the gap between them is very small. The gap between the lower and the upper plate, the stationary and the moving plate, is only 5 mm. Whenever the gap is very small, even if some different profile is given, I'm not talking about what you have to do in the exam. Generally, I'm telling you, even if you have some variation in the profile, but if you take that to be linear, answer will be very close to each other. Different profiles will give very closer answers as this distance between them keeps on decreasing and decreasing. So 5 mm is very small gap between them. Nothing is mentioned. Obviously, we are going to move ahead with this linear profile, with this linear variation. If we have the linear variation, I have already told you that it is mu v divided by h. Mu is a constant, v, velocity is a constant, h is a constant. Everything is a constant, right? Question is asking you the shear stress on the moving plate. Even if the question asked you, because it's not very much clear right now, based upon the memory based question, that whether it was asked on the stationary plate or on the moving plate or at any point between the fluid or the average value of the shear stress. Whatever the question is asking you, the value of shear stress is not going to change in this question. It will be a constant. You can see it does not depend upon the position. V is constant, H is a constant, mu is a constant, right or not? And that is very much correct, because you can see that velocity is getting differentiated once. So if velocity is linear, the differentiation of a linear variation is constant, right or not? So this tau will come out, if this was velocity, this tau will come out to be a constant, same throughout, right or not? So whether it asked it on moving plate, stationary plate or any other point, or average value or constant value, whatever it was asking you, this is going to give you the answer. But the point is, mu directly you have not been given, rho and nu are given to you. So to calculate that, you have to multiply rho and nu together to get the dynamic viscosity, multiplied by V divided by H. Now we just need to put the values and solve it. So upon solving it, you are going to get 80 Newton per meter square or 80 Pascal. The next question, very simple and doable, but still, if this was a NET question with a tight range, some of you would have done a mistake. I will tell you about that. Pressure measuring device attached to submarine records a pressure of 4 megapascal absolute, okay, at a depth h. So we have a submarine, and we know that submarine means it is below the water level, below the surface of the sea, free surface of the sea, right? It records a pressure of 4 megapascal at a depth h, okay. If sea density is given to us as 1080 kg per meter cube and atmospheric pressure is 101 kilopascal, okay, you have to find the value of h in meters by taking g as 9.8. Now this is slightly important. If it is NET question, if it was NET question with a tight range, let me tell you the explanation. So I have drawn a small schematic diagram here where a submarine is present at a depth of h. Nothing has been mentioned about the vertical dimension of the submarine, right? So you don't need to bother about whether H is up to top surface or bottom surface or up to the center of gravity of the submarine, because nothing is mentioned about the dimension of the submarine. Okay, so let's consider this to be just a point at a depth of H. This question is the one of the easiest question that can be asked from fluid mechanics. I am very sure that every one of you at least knew the concept which needs to be applied, because it's very basic. Okay, the pressure that submarine records at a depth H is 4 megapascal, which can be converted to Pascal. Okay, the pressure, we already know that if this fluid that we have, nothing is given about the density variation of the fluid, rather exact value of density is given. So we know that for such situation, the pressure increase as we move down the depth is rho gh. Rho is given as 1080, g value is 9.8, h you need to find out. Okay, the pressure at this point will then become P atm plus this value of rho gh pressure. The point to note here, important point, that question mentioned this to be absolute pressure. Suppose if this was mentioned as gauge pressure, if this was not the absolute pressure, then what will we do? Rather than doing P atm plus rho gh, to find out the pressure of the submarine, we use the absolute pressure. We added the P atm to the rho gh to get the absolute pressure and equated that to this value of absolute pressure. But if question mentioned this to be gauge pressure, then only rho gh we have to calculate. Now again, it's a memory based question. We have verified this question from many students that this was absolute only, it was not gauge. But just in case, if this was gauge, then rho gh will be equated with 4 megapascal and not the P atm. Yes, it is possible that question will give you P atm, still it will not use the question, not use the data of P atm. It has happened earlier in GATE that such data, redundant data, superfluous data as we call it, was given in the question, which is not used at all. I am sure this is not the case here. Absolute is known to us as far as verified memory verified question is collected. So P atm plus rho gh, rho g is 9.8 and not 9.81 multiplied by h. This was the silly mistake that I was talking about. The question mentioned the value of g as 9.8 and not 9.81. Now if it was a NAT question with a tight range, 9.81 may give you a slightly different answer. I know that variation will be in the decimal place, but still it has happened earlier in GATE that even the decimal place variations that are occurring, the range is tight enough to consider only the decimal place variation. Now let's see what happens, because specific 9.8 was given here. So if you take 9.8 and solve it, you will get the h as 368.38 meters. Again, you can verify such questions by your senses, by common sense, that answer seems decent. Approximately 368 meters is a decent depth at which submarine can be present. If this height comes out to be 3 meters, suppose due to any of the calculation blunder in units or somewhere else, 3.68 meter, that would have been incorrect. Submarine will not be staying at a depth of 3 meter. It obviously will be deep below. Alright. Coming to the last question of fluid mechanics that we have from GATE 2021 forenoon session. And this was one of those questions which should be very much doable and easy for most of you. Right? Because this was a concept which has been thoroughly in detail that I discussed when I was teaching the fluid mechanics, as well as when I was teaching the steam turbines, because the concept that we are going to use, although it's a question of Pelton wheel, which is of hydraulic machines, but even when we discuss steam turbines in case of thermodynamic applications, there also in case of impulse turbines, we discuss this concept that we are going to use here. So in both the cases we have discussed this. I am sure majority of you would have solved this. Even in test series such questions were present. They are slightly lengthier in calculation, but I always ensure that at least 10-15% of lengthy questions are present in the test, as the feedback that I have got from many students, some of the questions in both the sets, in forenoon as well as afternoon, were slightly lengthy. That's why I ask you to be ready for such questions. I am sure you understood the importance of the questions that I solve in the video course, as well as the questions that we solve in the test series. Okay, the question says that there is a Pelton wheel, diameter of the wheel is given, the N is given as 300 rpm, it's the rotational speed, deflection angle is 165 degree, the angle through which jet is getting deflected is 165 degrees. The velocity, absolute velocity at the inlet is 40 meter per second and the discharge is 5 meter cube per second. You have to find the power generated in megawatt. Now, at this point, we have collected two different types of data from students. Some of them said that efficiency was asked of the Pelton wheel. Some of them are saying that power generated was asked. Now, majority of them, earlier we were having the data of efficiency, but later on it got confirmed from majority that it is the power generated. So I am solving it for power generated. Even if you want to solve it for efficiency, it's just one step extra, right? So let's start the analysis of this question. So this is the diagram that I have drawn. We already know that in a Pelton wheel, the inlet triangle is a straight line like this, and that flows through the surface of the buckets of the Pelton wheel, and then it goes out like this, right? The angle through which it is deflected is 165. This angle it was going towards, and it deflected in this direction. So this 165 is the angle of deflection, something that we already talked about it, we already know about this. So this angle is going to be, this specific angle phi is going to be 180 minus 165, which is 15 degrees, right? So this is something that is given to us. We will use this data when we will discuss about the outlet triangle, right? Because this angle phi will be used at the outlet triangle. VR2 is going to get inclined at that same angle phi. So that we will discuss later on in the outlet triangle. Coming to the inlet triangle, we already know that U1 in case of Pelton wheel is same as U2 that we will discuss in outlet triangle, is same as the general value of U for this bucket in this plane, because all of them are at the same distance from the center, right? Please note that in this diagram, you have to recall what I taught you, that this shape is actually the cross section of the bucket. This cross section is at the same distance from the center of the wheel. So the value of N, the value of D or R is going to be same for all of them. So U1 and U2 will be equal to general value of U, which is pi d N by 60. Putting the values, D is given as 2 meter, N is given in RPM. Again, a point where silly mistake can be possible. If this was given in RPS, then this will not be divided by 60, right or not? So I'm sure that whatever memory basis question you have submitted, it is correct, it is RPM. So it will be divided by 60, you will get the answer as 10 pi. Now this is the expression that you have to use to calculate the power. We already discussed in detail about this expression. The beauty of this expression, because this expression of power, in this power generated in this case, has a sign of plus minus, right? And which decides this plus or minus? Whether it will be plus, whether it will be minus, it is decided by this factor VW2, whether that is going to be positive or negative, or in other words, whether the outlet triangle that we are going to make is going to look like this, or that outlet triangle is going to look like this, right or not? So we will discuss about that. For now, let us take that as plus minus. We will analyze the inlet triangle first, and then we will move and draw the diagram for outlet triangle. There we will recall those concepts. So coming to the inlet triangle or inlet line rather, this V1 is equal to U1 plus VR1. At the inlet, every velocity of the absolute is whirl velocity, the flow velocity component is 0. So V1 is equal to VW1, right? V1 is U1 plus VR1. VR1 we are interested in finding out, because U1 is known to us, V1 is known to us. Knowing the VR1 will help us in relating VR1 with VR2, right? We already know that relative velocity is that important parameter which relates the inlet and outlet conditions. This is something again that I repeated in fluid mechanics as well as in applied thermodynamics. So VR1 is equal to V1 minus U1 or U. V1 or velocity at the inlet, absolute velocity is given as 40 meter per second. U we calculated, put the value and get the answer of VR1. Now nothing has been mentioned in the question about the blade friction, this bucket friction or this blade friction. No losses we have to take because nothing has been mentioned. So automatically this value of VR1 will be same as the value of VR2 because there are no losses that are talked about. between the inlet and the outlet. So for the outlet, what condition we know? We know the value of phi, we know the value of VR2, and we know the value of U2 also, because U2 and U are same. On the basis of that, let us draw the inlet and outlet triangle and let us see whether the sign here should be positive or it should be negative. So in this case, as I have taught you that these two are the possible triangles at the outlet. In this triangle, the VR2 cos phi component is more than U2, right? This line is more than U2, or in other words, U2 is lesser than this line, or in the other case, U2 is so large that it crosses this line, crosses this part and reaches here, because it is a vector. The vector length represents its magnitude, right? So this is something that, as I have taught you, that we will take into consideration. So U2 is going to land up on the other side here, which clearly means that VR2 cos phi will be lesser than U2. We have the data with us, we have U value with us, we have VR2 value, we have cos phi or phi value. Let us put the value and get that which triangle is it going to represent. In the end, I will tell you one faster way also, where without even considering the triangle, we can find out the answer. That is something that I told you again when I was teaching you this topic. Let us come back to this discussion, this solution for now. So VR2 cos phi, VR2 value is this, cos phi is going to be 15. This phi is going to be this phi, right? This value and this value are going to be used here. We put the value, we solved it. You will get that VR2 cos phi is 8.219, but U2, which is equal to U or equal to U1, is 31.416. Clearly U is more than the cos component of VR2. So this is the right outlet velocity triangle and not this one, right? So using this velocity triangle, let us find out the value of power. All we have to do is just put this value in the expression of power. The point is that whether we are going to use a plus sign or a minus sign, and you can easily recall that I have taught this to you already, that for such case we are going to use a minus sign here when we have this velocity triangle where VW1 and VW2, this one, are in the same direction, because VW1 also in this direction. In this outlet velocity triangle, VW2 will also be in the same direction. So when you want to take the change, that difference will have a minus sign between them. And now you don't have to bother about the sign. We have considered the sign, so just put the value. That is one way of doing it. The other way is that always consider the plus sign here. As I have told you, plus minus, forget about it. Just use the plus sign here, and the value of VW2 that you are going to use, that value will always be used as VR2 cos phi minus U. This will always be used as VR2 cos phi minus U2. Now, whether this value is positive or negative will change this sign. For example, in this case, VR2 cos phi is less than U2. So automatically this value is negative. Automatically a negative W2 will make this positive as negative. So automatically the sign of plus or minus will be considered if you just apply this funda. So I am sure by using any of these methods, you would have solved this question very easily. Let me put the value and get the answer. So this expression can be further simplified like this. Mass flow rate can be written as rho Q. VW1, as it is plus minus sign, as I told you, minus sign will be coming here using the first way of solving it. In the other way, just use the plus sign, and in place of VW2, use VR2 cos phi minus U. You will always get the right answer. So VW1 value, we know it is equal to V1 value, which is 40. So this is 40. Rho value, it has not been mentioned here, but I am sure question mentioned it, or it mentioned water. So it is going to be 1000. If nothing is mentioned in a Pelton wheel, water is used. So 1000 density, 1000 kg per meter cube we are going to use here. Q is known, VW1 value we put. VW2, as we calculated here, this VW2 is the difference of U2 and VR2 cos phi. You do that, you put all the values, we will get VW2, right? Because this calculation we have already done actually. We only have to subtract both of them and we will get VW2. So we are going to put that value here of VW2. U value we have already calculated. Just put the value, solve, and get the answer in megawatt. This is something, again, a point to pay attention towards. To convert watt to megawatt, just divide it with 10 raised to the power 6. So this is how this question can be solved.